Alright, we're gonna kick off chapter 7, I think. Yeah. We're gonna start off chapter 7 with exponential functions. This whole unit's gonna be like exponential functions and logarithmic functions. We're just gonna start off with exponential, and we're gonna look at actually graphing them. So it's gonna be pretty straightforward and easy to begin with. That way, we start off with something a little bit on the lighter side. So the first thing you need to know is the exponential parent function. That's going to help you with a lot of what we do when we get into transformations, and that is f of x is equal to b to the exponent of x. So b to the x. So b to the x, or whatever number that is going to be your parent function for your exponential functions. Now, if that b is greater than 1, that means your function is an exponential function. So it's going to be exponential. So I'll just abbreviate it. I'll say exp. And it's going to be a growth. So it's going to be an exponential growth function, and it is increasing, which growth, increasing, those two kind of go together. And then the opposite of that is if that b is less than 1, then your function is going to be, it's still going to be an exponential function, but now it's going to be an exponential decay. And it's going to be decreasing. So I guess you could say decay, decreasing. And that means simply, when we look at a graph from right to left, which we'll just look at this graph, if a exponential function has b greater than 1, then it's going to look something like this. It's going to go upwards, going from right to left. And if that b were less than 1, it would go like this. So from left to right, it would be almost going downhill. And exponential functions always have that little curve. And what they do actually is, you'll see when we graph them, there's a line that those graphs will go towards, but they won't ever touch it. They won't ever cross it. That's called an asymptote. So you could just say line that is never crossed. Or you could just say the graph doesn't cross that line. However you want to say it, that's what an asymptote is. So when we look at actually graphing these, we're going to look at one exponential growth, one exponential decay, and your homework's going to actually come from these notes. And don't worry about the end behavior or the y-intercept. We're just going to worry about domain and range and the asymptote. So let's look at number 1. The easiest way we're going to do these is just setting up a x and y table and plugging in those values. That's the easiest way to do these. So we're going to get an x and y table anytime we graph these, and we're just going to start off with -2, -1, 0, 1, and 2. That gives us 5 points there, and that's plenty for what we need. So pretty much just have 0, -1, -2, 0, 1, 2. That's really all you need. So those are all of our x values. We're going to plug those in for this exponent of x here, and that will give us our y coordinates. So we're going to do that for each one of these. Now I'm going to skip this part just because, to try to shorten up this video. You can plug each of these into your calculator. So when you plug in a -2 exponent, you just plug in -2 as your exponent like you would any other number. So that's going to give you 0.25 for y. When x is -1, you'll get 0.5. When x is 0, you'll get, you'll get 1. When x is 1, you'll get 2. When x is 2, you'll get 4. So we're just going to take all of those, plug them in, or plot those points, and then we'll graph it. So let's start off with -2. So 1, 2, and then it will be at 0.2 or 0.25 on our graph, which I'll try to zoom in to make it a little bit closer. So that would actually be right about there. It's really close to the x-axis. Then we've got -1 and 0.5. So that's going to be about right in between there. Right in between 1 and 0 on the x-axis. Then we'll have 0, 1. That one's pretty easy right here. We'll have 1, 2, which will be at 1 on the x-axis up to 2 on the y-axis. And that's not where I wanted it. Right about there. And then 2, 4. So over to 2 on the x-axis up to 1, 2, 3, 4 on the y-axis, which would be about right there. Now, these always will go in a curved shape, but just make sure your left side, it should go in a straight line almost along the x-axis, but it won't ever cross the x-axis, and then it'll curve up like this. So that's what an exponential function looks like. Now, an easy thing to figure out, well, first of all, we'll look at the domain and range. Then we'll get to the easy part. So the domain and range, we've done this before, but just a review. So your domain is going to be looking from your x, on your x-axis. So from left to right, where does this graph cover? And you'll see here, it kind of has these arrows on the side. So that's a little indicator that on the x-axis, this is going from left to right. It's covering pretty much everything on the x-axis. So all these values are going to be hit. So that's going to be all real numbers. And then when we look at the range, this is kind of an easier part to me, I think, too. So you want to look on the y-axis. So from top to bottom of this graph, we can see at the top of this graph, it's going to keep going upwards and won't stop. But here at the bottom, it flattens out and doesn't cross that x-axis. So that x-axis is actually y is equal to 0. So if we want to say what our range is, we're going to say y is greater than 0 because our graph is above everything greater than 0. And then the easy part for your asymptote, your range is kind of an indicator of what your asymptote is. So your asymptote is actually y is equal to 0 because that graph stops at y is equal to 0. So that's your asymptote. It doesn't cross any lower than that. All right, so that is a exponential growth. Now we'll look at a decay problem. And the decay is just looking at this b, and this b is less than 1. So that's really the only difference here, is that it's just graphed a little bit differently. So let's look at this. We're going to create an x and y table and start with -2, -1, 0, 1, 2. We're going to take each of those values and plug them in for x. Now you can do this with your calculator, so I'm going to skip this step just to save us some time. So if we plug in -2, we'll end up with 4. If we plug in -1, we'll end up with 2. Plug in 0, we'll end up with 1. Plug in 1, we'll end up with 0.5, and we plug in 2, we'll end up with 0.25. So we're going to graph those. So we need a point at 0, or at -2, 4. So that would be -1, 2, up to 1, 2, 3, 4. That would be right about here. -1, 2 would be right here. 0, 1 is going to be here. 1, and then 0.5 is going to be, try to get it right in between 0 and 1 on the y-axis, and then, or at the y-axis. And then 2 is going to be 0.5, which would be right about here, almost touching the x-axis. So this graph is going to actually start all along this x-axis, and then it's going to curve up and just keep going. So you can see the difference between these two. This is a decay because it's going downhill. The other one's going uphill. That's an exponential growth. So now let's look at our domain and range. So our domain, I think, is pretty easy because if you look along your x-axis, so from side to side, all of these x values are going to be hit because these arrows are telling us that from side to side, which this top arrow is diagonal, it's just going to keep going. So our domain is going to be all real numbers. And then our range is going to be right along our asymptote, which if you notice this flattens out, this graph doesn't go below 0. So that means our range is everything above 0. So y is going to be greater than 0. Or you can just say pretty much that graph goes everywhere above 0. And then your asymptote, you can take it from your range, or you can draw a little line just under where everything flattens out, and that line would be at y is equal to 0. So for graphing these to begin with, these are pretty simple and straightforward, and then the next section we'll get into transformations. But to begin with, you need to know how to graph each of these exponential growth and decay problems. And your actual homework, which I'll put this in Google Classroom, is going to be 2 from the notes, 4, and 5. And you're not going to be worrying about the end behavior or the y-intercept. You're just going to worry about domain, range, and the asymptote.